Assalamu alaikum. Hello and welcome to my presentation of simulation of assembly line and automated storage with FactoryIO. We have the planning of the presentation, general introduction, a definition of warehouse, the factory plan, and then the evolution of warehouses, and then the general view of the complete process, some ladder program details, and the use of our HMI, and then how we're going to extend the program and make it far more better, and then a conclusion. General introduction. As stocks and warehouses increase their capacities, vary their types of commodity, human manual organization can be less useful and less precise. Use distribution centers, computerization arrangements can help improving efficiency, time consumption, and even costs. To better understand how is an automatic warehouse controlled, we have simulated its performance through the FactoryIO, connected to the PLC S7 1200. In this video, we're gonna have this general introduction and talk in the PowerPoint, and then we're gonna have the videos and a brief program of the ladder that we use to make this small projects. The definition of warehouse. As we all know, there is like famous warehouses as the Amazon warehouses and stuff, or Bosch that use the Industry 4.0. Anyway, a warehouse is a building for storing goods. Warehouses are used by manufacturers. They are usually large plain buildings in industrial parks or the outskirts of cities. They come like in big racks and stuff, so they need to go outside of the cities to make them large as they can. They often have cranes, forklifts, and loading docks for moving goods, as we see in this picture. The evolution of warehouses. We have the warehouses like from centuries ago. They used to store food and stuff. This is the picture of some of the old first warehouses that we still find in the current world. And then there's some medieval warehouses and the industrial one, and the 20th century's warehouses that use the electrical stuff, and they are far better and far more easily to access and store goods and stuff. Okay, and now for the factory plan. We have on each side 2 conveyors, one to bring the base piece and one for the lid piece. And the other side also, they just differ in colors. There is green color and there is blue color for the pieces. Each conveyor contains a clamper, some sensors, and a picker, which gonna pick the green or the blue lid and put it on the base. This is the base conveyor, and this is the lid. The lid gonna be picked from here and be put on the base. Same thing on the other side. It just differs from blue and green. And now in the middle pick and place, it's gonna choose the first one, which is on the left side, and then put it on a stackable box, which we're gonna get from this big conveyor. This is the main conveyor that we're gonna use for both green and blue. It's gonna be picked from this place and put on here on the stackable box, and then when it's done from this side, it's gonna go to the other side and keep moving from left to right, like picking the green one and then the blue one and keep alternating between them. And then this conveyor gonna move to this spot right here. This spot, it's a conveyor which is going to transfer the pieces to the left or to the right, depending on the color, which we have here this small octagonal thing. This is a sensor. This is just a symbol for the sensor. This sensor is going to detect the color and then move to storage 1 or 2, depend on the color. If it's blue, it goes here. If it's blue, it will go to the other side. We're gonna see a video about this. This is just like a small plan. It's not so big of a deal. We're gonna see the 3D simulation. Okay, now we have the material we used. This is the obvious one, the PLC, the S7 1200. We're using the one with CPU at 1214C DC, with this reference, which you can see there is the CPU status LED, the power connector, the removing inputs and outputs, the removable input wiring connectors, sorry, and we have the memory card slots, the input status LEDs and the output ones, the hinge door, and there's the Profinet connector. It's under there, and the signal board, which has the battery and stuff, and communication board. And we have the power supply. This is the power supply that we're using. And we have this HMI, TP900 comforts. And then we have the Profinet that we're gonna use to connect to program, first of all, the PLC with the laptop using TiaPortal, obviously, and then do the simulation. We're gonna use the RJ45 patch cable for Profinet, and it's gonna look like this. And obviously, to use the HMI, the PLC, and the laptop all at once, we need the undersea switch Ethernet. We use this one with this reference, Scalnes X208 to be precise. The connection is going to be like this. We have the laptop that we are currently using, the Lenovo G500, and the HMI which is going to connect in here, and the undersea Ethernet is going to be connected to the PLC, and the power supply going to connect the industrial switch and also connect the PLC with power. Okay, this is a picture from the FactoryIO. As we previously stated, that's in the factory plan, this is the green assembly line, and this is the blue one. So the lid piece gonna move in here, get clamped, and then get picked by the 2-axis picker. And then once it's only gonna be picked once there is the lid one gonna come, and then it's gonna be picked and placed on once the base is already there. So if it's not there, it's not gonna be picked until the base is ready. And then it's gonna move forward until it's reached this place and be picked by this pick and place machine. And same thing goes to the other side. It's just a simple process. It's not that complicated. And then the stackable box is gonna be waiting for here until the pick and place, pick the product, which is green or blue. And once it's already done picking it, the stackable box is gonna be moved until it's in the sorter. The sorter is gonna choose which side she's going to move the product. Either it's blue, which is gonna go to the stacker crane number 1, or it's either it's green, it's gonna be moved to the stacker crane number 1, or it's blue, it's gonna move to this. It's all color sorting. It's simple process. And we have the switchboard and the assembly lines. This is like closer picture of it. This is the blue one, 2-axis picker, and there's the pick and place, which you're gonna see here zoomed in, and the sorter. And the sorter, it's just like there's a conveyor, and there is this green, orange chains that's gonna decide which move here or here, which gonna be decided by this one. And we have the stacker crane. This is like a picture of the only stacker crane by itself, and this is where in the projects. Now for the program details, I rather not go through this like in the PowerPoints, but I want to go using TiaPortal because it's way better. So we have for our program, we have in TiaPortal program blocks. We're going to talk about the program blocks that we are using, and then we're going to just take a brief look to the ladder program. We're not going to go to the extra details to make the video shorts and to make it easier for editing. Bear with me, the TiaPortal is a bit slow for me. Okay, first of all, in the main OB1, we have this special function. This special function is, you download it from the FactoryIO, and you just drag and drop it. Actually, when you download, you're gonna download kind of a project like this one, and I just like copy and paste it in my other programs that I use the FactoryIO simulation, because I don't have a real PLC except when I go to the lab. So this function is mainly for the FactoryIO to make the simulation good. This is for the S7 1200. There's another one for 1500. And if you're using S7 300 or 400, there is no problem with that. We have the FC2, which is the pick and place for the pick and place machine. And then we have the steps for it from 1, 2, 3, 4, 5. And this is for the blue one. And there is 6, 7, 8, 9 for the green one. As I said, I'm not going to go to the extra details of the ladder programming. And we have the resetting one in here to reset everything for the switchboard. And the sixth network, we have the start all, which when we're going to press, everything going to start the lights. And I think I did like start all one for the sorter, or the conveyor, which is like a separate one. Anyway, for the OB 123, we have one for the blue and the green, like the blue conveyor, which we are using the function block. This, like, everything is sorted. I try to make it as beautiful as I can. We're gonna call the function block number 3, which is for the pick and place, for the blue picker, sorry. When I say the blue picker, I also mean the conveyors and stuff. I just named it the blue picker, and in the blue picker FB5, I used like several networks to make it even fancier, and obviously there is the one which I'm gonna say, which states that the conveyor, the picker is busy, and there is the clamper one. So the clamper either is busy or ready, or this is where it gets messy a bit, because when you're reading this, you're gonna read some other inputs or outputs that are related to this clamper, and some of them are related to the other picker, and it's all gets related, not busy. Anyway, we have one for the busy. I just named it busy. Like, mind the naming. One for the conveyor and one for the picker. Like, and everything contains the HMI. I just added there, so the HMI gonna function well. And the production, it's the end of the conveyor. That's called the production. This is like the same one as this is the blue, and the other one is the green. They are kind of the same. They are basically the same, not even kind. And there's the sorter one, and the S crane, which means the stacker crane number 1 and stacker crane number 2. This is like the most of the the thing that took my time is that this one, because I had to use sensor in every spot, so it's 54 sensor, and the 55th sensor is for the stacker when it's in the right position, like position 0, 0, if I can say that. I use this function block number 1. It's the same as the function block number 2, except this one is the left one is related to the left conveyors, and the right one is related to the right conveyors. Anyway, okay, as we said, this is the function block number 5, and we have some tricks within here to assure that we're gonna fill every spot. As I said in the video that I recorded before, that the brilliant idea of this project is that it's gonna automatically store everything in the right spot. If we empty like spot number 19, it's gonna go straight to that. As we see here in the ladder program, we're just gonna focus on a small bit of this program. The spot number 1 is independent from any other spots. All the thing we care for is that the stacker crane is in the start position, which we named it spot 55, or the target S55, or when it has the number target 55 or 0, depend on if we already resetted and started from 0, or the S crane was stacking and it's going back to its initial spot. Basically, for the stacker crane, every spot above 54 is 0, so because it has only 54 spots. I can even change this to bigger or equal. It's not a big deal. Anyway, this spot number 1 is independent, so we don't have to check the spots prior to it to stack anything in here. So we're just gonna see if it's empty, we're gonna stack in number 1. But from S22 until the last spot, S55, this is a long program, as you see here, S55, every time we need to check the spots prior to it. If the spot prior to it is full and this spot after it is empty, we're gonna stack in the empty one. For example, we're gonna go to a random spot and we say S42 is not empty. S42 is not empty, which means it's indicating a 0. So this program is not gonna be it's not gonna be executed. It's gonna be stopped right here. The green line in TiaPortal is gonna be stopped right here, and nothing's gonna move forward from here. So this is kinda not being executed. So we're not sorting, we're not storing in the spots 43. So we don't have a problem. It's good for us. As we said, spot number 45 is not empty. So it's indicating 0. The sensor of spot 45 is indicating 0. So we go in the program to spot 42. This is the one for spot 42. The program is not going to execute from, it's going to start from the first one and start going down. We just took a random example. So the program going to say, okay, it's not empty. And if it's like, it checks in many cycles, so it doesn't do it like I'm doing it right now. I'm just trying to explain it furthermore. And spot, let's say, spot 41 is full and spot 42 is empty. So in this case, all of this is gonna work perfectly. Well, it's not starting from here. It's starting from here to give it to the target number 42. So this is true and this is true. Obviously, these need to be true because we don't want the lifter to extend the arms of the lifter or forklift, if I may say, and then end up messing up the whole project. I had that problem, so that's why I'm doing this times T on, and T off, because sometimes I had the forklift moving arms, extending it before even reaching the spot. So I had to do some time, to give it some time, so we don't destroy anything in the process. So in the simulation, sometimes these doesn't work perfectly, or maybe it's just my slow computer, I don't know. Sometimes these doesn't perfectly work, like they slow down or they lag sometimes. Maybe it's the FPS drop or something. They don't indicate the proper one. I see in FactoryIO they indicates one, but I don't actually see it in the TiaPortal, or vice versa, I don't know. So we had to improvise by using many T-on and T-off, like a lot of timers. And for another some odd reason, I couldn't use the multi-instance timer, so I had to fill them one by one. I mean, if it worked, I could just copy and paste the same stacker crane, but it didn't work. Okay, we were using the OB 123. I'm just gonna click from there. And the stacker crane 2 is the same thing. And the other things are just the same. They're just functions that's being called from the OB1 or the OB123, as we already shown in this small plan. The FC1 is the one for the FactoryIO, which is going to contact the simulation, make sure it's all working well. The OB1 is the main OB. And the OB123 has all these stackers. And the FC2 is for the pick and place, which we're going to see even a better view of our program. Oh, wait, I'd rather open this one. Okay, as we see here, we're gonna put the names on. Okay, now we have our simulation, which we're gonna have some better perspective than the video. As we said, we have to put it on auto picker. I removed the manual one and did reset all. So if we press an emergency button, we need to reset everything. We need to reset everything and then start again. So in case of a big emergency, we're just gonna, when we click this, it's gonna stop everything. This indicator is gonna stop. This is the danger indicator. And then we have to reset and then go again to auto picker. So we don't have problem of someone in the, I don't know, the control room pressing this by mistake. As we said, this is the picker with the sensors, as we see here. I can just keep the sensors. These are the sensors of it, and these are the actuators. This is the blue line. Okay, I'm gonna activate both sensors and actuators. And this is the stackable box one. I did if it's ready or not. And we have the conveyor. I added these so we can make sure that the stackable box is not moving to any of the other sides. So to make it neat and clean. And this is the sorter with the color sensor. And this is the stacker. As we see here, every spot has its own sensor. I know if it's real projects, it's going to cost a lot, but it's not going to cost any. Just one person can manipulate all of this. Doesn't need much. And we have this sensor which indicates that our stacker crane is in the exact position so we don't have a problem with it. And we have these limiters, like when you move it, it's gonna indicate that it's not in the middle. So it's all from FactoryIO. I didn't create this. I just made it all together and programmed it. So that's it. That's the project in FactoryIO. This is the video that I recorded to show in my presentation. Okay, in this switchboard, let me tell something. In this switchboard, it's need to be on the auto. The switch need to be on the auto, not the manual one. So when we press start, it's going to start moving. And this is the obviously this is the PLC simulator using TiaPortal, which is in the background, and this is FactoryIO. Now we did resets. It was already indicating the stop button. Now we click start and we wait for the process. As we see here, this is the green lid and this is the green base. We already assembled one piece. As you see, you just focus on one side because it's the same process. Okay, now it's pull on and the conveyor is moving. This conveyor stops when there is a piece here. So everything is like related with the, like each part of the conveyor or machine is related to the previous part. For example, I had the problem where this conveyor kept getting like a lot of stackable blocks, which doesn't make it easier for the color sensor to censor the right color. So I had to make it related to this whole thing. If this is working, the conveyor is going to stop. If the conveyor stopped, the pick and place need to be stopped. If the pick and place is stopped, then this conveyor is stopping and also this. And if this conveyor and this is not working, obviously, these pieces are not going to be moving, so this machine is not going to pick it and place it. It's all like related. And I think that's the hardest part in the ladder programming, so it's need to be all related, and there you start to see a lot of inputs and outputs in the process, and it sometimes confuses you. Okay, now we did the blue one and now the green one. I have the simulation right here with the FactoryIO. I'm gonna try to record and simulate on this computer. I don't think if it's gonna actually work. Now we're gonna move. Okay, now we see it's sorting the colors. It's putting the good and the hardest part in this project is that let's say in all the storage places they're all full, and someone decides to pick number, I don't know, 19 or so, I don't know which number is this, decides to pick this one, okay, this precise one, and everything is full. The HMI is indicating everything is full to the brim. So when we pick this one, and obviously if it's all full, this conveyor gonna stop, and same process as I stated before, everything gonna stop. Like obviously it's gonna stop moving because we don't have any storage areas, so this crane gonna command the one previous to it to stop working, and everything is related, so it's all gonna stop. When we, this sensor right here, because there is like 54 sensor in every spot, that's a lot of sensors, but it's like more automatic. If this spot is empty and every spot is full, the crane gonna go to this spot. It's not gonna move or just like, it's not programmed to be counting like 1, 2, 3. It's programmed to find each close spot, each close empty spot. we're gonna play an example for this. I already recorded an example for that. Okay, it's just the same process now. Now it's kind of boring. Okay, now we see it's stacking one by one. And now we're gonna move to the other video so we can see it better. Okay, I'm typing right here that's forcing all spots except one test. This is just to... Okay, now in FactoryIO you can force a sensor to indicate that it's sensing something without it actually being there. So I didn't want to waste time and wait for every spot to be filled. I just forced every spot. Okay, we're gonna move a bit forward. Okay, now every spot is forced, every spot in the screen, except I think there is a number of, I think 19 or... Now it's moving to the correct place, which is not... Yeah, number 19 is not forced. So what the ladder programming or the PLC is reading, ladder programming is doing, or the PLC is reading, is that she's saying this spot is full and also this, and this, until this spot is empty. So what we're gonna do, we're gonna go to the empty spots and just fill that spot, okay? And then it's gonna go to the spots after it. I think I did it both sides. Yeah, I think you got the idea. Now, because every spot is full, it's just waiting there. And since this is the green one, it's just gonna move the green product to this, and then the lifter gonna wait. The conveyor in here is just gonna stop and wait for the crane to not be busy, because the indicator, the input in here is the stacker crane busy. Stacker crane number 1 is busy. So it's gonna stop and wait for it. Until then, nothing's gonna happen. Like, we have full stock and we're just gonna wait. Yeah, that's it. This is the brilliant idea of this project. It's fully automated and it's not gonna cause you some problems. Okay, now we go to our PowerPoints. While we skip all the boring program. And then we have the HMI display. This was the last minute design. We have the start and stop buttons. Actually, I don't have the actual HMI, and I can do it in TiaPortal, but it's just gonna take a lot of time to load, and it's gonna slow my recording. So we have the counters in here and the resets all, and the reset all button, on and off. And this is the reset button for the, sorry, I made a mistake, for the counters. And now we have the, if you can switch between screens, either clicking here or here. And we have the counters, and we have the factory plan. I try to make everything lit up a bit, or change the color for it to, when it's working, but I decided that it's better like this. We can switch screens to stacker number 1 or stacker number 2. And I just made it simple design, like a beginner design. Each spot that's not empty, it's gonna indicate a red dot. And this is for the stacker crane. When it's in spots S55, as we said, like in the start position in here, it's gonna indicate red. If it starts moving, that means the stacker crane is busy, so it's not gonna indicate the red, it's gonna indicate green. This is for the step number 1, and that's it for the program. Now let's talk about extending the program. To obtain greater effectiveness and for maximize exploitation of the automation in the warehouse, we recommend the following: using a retrieve system. I actually tried to make it like complete this whole project and make a store and retrieve system, but it's already too much. It's already a big program, and the presentation of this was already long enough, and I didn't have like the whole day to explain it, sadly. But like this is enough for now. Not for me, but for now. As we said, we can use a retrieving system. We can connect the PLC network to the connection and monitor it remotely. Conclusion: the integration of automation in warehouse and stocks is essential for keeping pace with competition in markets, as it serves in improvement in productivity through balancing, increase in available knowledge, bundling of product flows, combined use of production flows, control on the system, uniformity in the process, improved efficiency. Thank you for your attention.